Today our topic is classifying angles, so our essential question is how can I classify triangles and apply some properties? Triangle, a polygon with three sides. That's what a triangle is. Naming, we draw a triangle and we use the three vertices. So for this triangle, it's vertices A, B, and C, so we call it triangle ABC. Classifying triangles by sides, this should be review, but scaling is no congruent sides. Isosceles has two congruent sides, and then equilateral has all three sides are congruent. Classifying by angles, we have an acute triangle, has three acute angles. Remember, acute is less than 90 degrees. Right triangle has one right angle. Obtuse triangle has one obtuse angle, so greater than 90 degrees. And then an equiangular triangle has three congruent angles, which is going to also have congruent sides. An equilateral triangle also is equiangular. Also on your resource sheet is angles. So when the sides of a polygon are extended, other angles are formed. The original angles are the interior angles, and the angles that form linear pairs with the interior angles are the exterior angles. So if we take any shape, here's a triangle, extend the sides so that the sides are actually lines instead of segments, you get angles on the outside, which are then exterior angles. Classify triangle PQO by its sides, then determine if the triangle is a right triangle. So we can tell by looking at it that it's not going to be an equiangular or equilateral triangle because all three sides are not going to be congruent. We can tell that by seeing it. But we should check and see if it's an isosceles triangle. Check and see if these two side lengths are congruent. So we need to use our distance formula. So the distance between P and Q would be x2 minus x1 squared plus y2 minus y1 squared. 6 minus negative 1 is going to be 6 plus 1, so 7 squared plus 1 squared. That would be the square root of 50. And then we find the distance between Q and O. We'd have the square root of 6 minus 0 squared plus 3 minus 0 squared. Square root of 6 minus 0 is 6, so 6 squared, and then 3 minus 0 is 3 squared. 36 plus 9 is 45. So they're not the same length, which means this is a scalene triangle. All three side lengths are different. And then determine if it's a right triangle. So if any angle is going to be a right angle, it'd be that angle. So we want perpendicular lines, which means our slopes need to be flipped and opposite. So we need the slope of this line, which would be down to right 1. So that is a slope of negative 2 over 1. And then the slope of this line right here, which would be up 3 over 6. Which would reduce to 1/2. 1/2 and negative 1 over 2 are opposite reciprocals. So yes, it is a right triangle. Next piece, theorem 4.1, triangle sum theorem. The sum of the measures of the interior angles of a triangle is 180. That should also be review, but now it's a theorem. We do have a theorem that states that the angles sum to 180. Theorem 4.2 is the exterior angle theorem. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So we're saying that if we extend one of the sides, this exterior angle is going to be equal to the sum of the two angles that it doesn't touch. So in our example here, we have find the measure of JKM. So find the measure of JKM. This angle right here. Well, based on our theorem, we know that this angle is equal to the sum of these two angles. We have 70 plus x. Solve for x minus x on both sides. x, add 5 on both sides, equals 75. Plug that in here so we can solve for the measure of that angle. We do 2 times 75 minus 5. 2 times 75 is 150, minus 5 is 145. So the measure of angle JKM would be 145 degrees. Corollary to the triangle sum theorem, the acute angles of a right triangle are complementary. Should make sense. If you have all 3 angles are going to sum to 180, one of them is 90, the other 2 have to make 90 as well. Find the measures of the acute angles of the right triangle in the diagram shown. We know that these 2 are going to sum to 180, or to 90 degrees, excuse me. 2x plus x minus 6 equals 90 degrees. We have 2x plus x is 3x minus 6 equals 90. Add 6 to both sides, we get 3x equals 96. Divide both sides by 3, we get x equals 32. So find the measures of them. Plug 32 in for x for both of them. 32 times 2 is 64 degrees. And then 32 minus 6 is 26 degrees. Next piece is section 4.2, which is triangle congruence. So how can I apply congruence to triangles? So we're going to start talking about how can we prove triangles are congruent. Congruent figures. Our definition for congruent figures is all parts of one figure are congruent to the corresponding parts of the other figure. So then congruent polygons, to be more specific, corresponding sides and corresponding angles are congruent. Remember, congruent means they have the same measure. So if we look at our examples, we have congruent, have the same size and shape. They can be oriented different, so flipped upside down or on their side, but they have to have the same size and shape. Not congruent would be different sizes or different shapes. So these triangles over here are not congruent to each other because they have different sizes and shapes. On your resource sheet, we have this piece on congruent statements. So when you write a congruent statement for 2 polygons, always list the corresponding vertices in the same order. You can write congruent statements in more than one way. All right, so we want to make sure we're listing corresponding pieces in the same order. So we would say that the corresponding angles are A and F, B and E, and then C and D. So if we say, we would call it triangle ABC, and then to correspond, we'd have to call it triangle FED. So they have to correspond one to the other. Since A is congruent to A, we have to put A first. And then if we put B first, B is corresponding to E, so we put E next. And then if we put C third, C corresponds to D, so it has to be listed in the same order. Example 1. In the diagram, DEFG is congruent to SPQR. So this is why we list them in order, because now we know that angle D is congruent to angle S. So we can say angle D is congruent to angle S. Just because they're oriented differently doesn't change it. Then angle E is congruent to angle P. E and P. And then angle F is congruent to angle Q. 1, 2, 3. 1, 2, 3. And then the last angles are congruent to each other, so I'm just going to leave those empty for now. Find the value of x and find the value of y. All right, so we know that 6y plus x, so to find y, we're going to have to solve for x first. So we're going to need to use this side length here. So QR is at the end, so that means it's going to be congruent to FG here. So we would say that 2x minus 4 is equal to 12. Add 4 to both sides. We get 2x equals 16. Divide both sides by 2. We get x equals 8. So that'd be our value of x. X equals 8. Now that we have our value of x, we can solve for our value of y, because now we know that this angle Q is equal to 6y plus x, which is 8. Now angle Q corresponds to angle F, so we look at angle F, which is 68 degrees, and we can set these two equal to each other since they are congruent. 6y plus 8 equals 68, minus 8 from both sides, we get 6y equals 60. Divide both sides by 6, we get y equals 10. Theorem 4.3, third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent, because then they're going to sum to that 180. So find the measure of angle BDC. We have this angle is congruent to this angle, A is congruent to B. Then C is congruent to D. That means our third angle is going to also be congruent. So it can help if we split up those triangles, A, C, D, and then B, C, D. We have this angle here is congruent to this angle here. These angles are congruent. That means we know that these angles are going to be congruent as well based on that theorem. So A is 45, which means B is 45. Angle D here is 30, which means this angle is also 30. So find the measure of angle BDC, this angle right here. These two sum to 75, so this angle right here needs to be big enough to make 75 plus that angle 180, which would make this 105 degrees. Example 3 in the diagram, what is the measure of angle DCN? By definition of congruence, what additional information is needed to know that triangle NDC is congruent to triangle NSR? I would like you to try this problem on your own, and then we will go over it in class, next class period. Thank you for watching this video, and please subscribe to my YouTube channel.